let's see here. Yeah, in the definition for a quadratic equation is an equation that's in the form of the following. Okay, in the form of the following. It looks like this. Right here. So it looks like this: ax squared plus bx plus c is equal to 0. Okay, now there is something about. Okay, this is important right here, so it goes in the cloud here. There is something about this particular equation that makes it quadratic that we need to focus on. Does anyone see it? Yes?
Ax squared.
Yeah, the squared part. You're absolutely right. Because it is squared right there, that's the part that makes it quadratic, right? So I have to add a little bit to my definition. I have to say that a cannot equal 0. Why can't a be 0? Because what if it was 0? What would that give us?
This is 1.
Okay. There's also something else that's very important about this. It's written in a certain way. Does anybody see what it is? Standard form, yes. Why? Because it's standard. That's not good enough. Why is this in standard form?
Because it's ABC.
No.
Oh, powers are in the support.
Because the powers are decreasing in order from left to right. Okay, very good. Okay, there are 3 ways to solve a quadratic equation. Okay, so let's list them out. 1, 2, and 3, and I will bet that you the square. Okay, so these are the 3 ways that we know how to solve a quadratic. Okay, the first way is by factoring. You can check the factoring with graphing. Okay, we're gonna work on that. I'll show you that today. Second way is completing the square, and the third way is the way that works guaranteed every single time, called the quadratic formula. Today, ladies and gentlemen, our focus is right here. Okay, so we're going to focus on factoring, graphing, and completing the square, and then of course this is block day. Okay, so now you know where we're going. All right. All right, here we go. We are on to our third box, and this one is called factoring. Okay, so can we please solve this quadratic equation by factoring? It is x squared minus 5x 6 and 1.
-6 and a positive 1.
So you want to do an x and an x. You want to do a -6 and a positive 1. Is that right? Let's see if that works. That doesn't work.
Why not? Oh, wait, what?
What do you think, Quinn? Quinn, can you say it one more time, please? Yes, -2 and a -3. That is correct. Now, I would like to point something out. Do you notice that you have a number times a number and it equals 0? Does that ring a bell for anybody? Yeah, what does that mean that we have to apply? Apply what? Zero product property. Very good. The zero product property. Okay, who remembers how to set it up? Yes? Yeah, put them out. Good. Yeah. Remember, we have 2 numbers multiplied together to equal 0. 2 numbers multiplied together to equal 0. That means that one of the 2 numbers has to be 0. So we set it up and say x minus 3 equals 0, or x minus 2 is equal to 0. So solving these little tiny equations, I get x is equal to 3 as one of my solutions, or as x is equal to 2 as the other solution. If I have 2 solutions, I can put them in a solution set and give my answers 3, 2. Everybody agree that this is the right answer for this? All right, great. I would also like to show you now how graphing is involved with this. So I'm going to pull up a graphing application here, okay? So the equation was this. It was x squared minus 5x plus 6, right? So I'm going to go ahead and create the graph. Oh, there we go. Whoa, that was cool. Now, check this out. I want to make the connection with all of you, okay? I want to make the connection with all of you that the answers that we found over here, which was what? 3 and 2, tell you something about the graph. And I'm able to zoom in and move this around. I can manipulate this all that I want. Hey, does anybody see anything kind of cool? Oh my gosh, what do you see? Yeah, look at that number and that number. Are those numbers significant? Yeah, what does that mean? That our answer was right, but our answer, when we solved for x, it told us something about the graph. What did it tell us? Yes, Adrian.
Where like the parabola crosses the
where the parabola crosses the x-axis. There is a connection between the solutions that we're solving by factoring and by graphing, and no one really puts that together. So I want to show you that we're not making stuff up and that this stuff is very useful in terms of where it's going to show up on the graph. They're making fun of me. Nothing. I know. I'm very angry at my sixth period right now. I'm very angry. All right. All right, let's get back together. Let's move on to our to part B. I'm gonna go part B here. Okay, I'd like you to solve this, please. X minus 3 quantity squared is equal to 81. No, not new box, part B. Square root this, and I want to square root that. Why would I want to square root the left side? What will that do for me? Yes. It takes away this with this, right? So that means I have x minus 3 is equal to plus or minus, yikes, 9, thanks. Plus or minus 9. Now, why do I have a plus or minus there? Because both of those things squared equals 81, and also I have a quadratic equation, so I can have up to 2 real answers, so I don't want to leave anything out. So now, if I solve for x, I get x is equal to plus or minus 9, and then adding 3. So there are 2 directions I can go with this. I can go the positive direction or the negative direction. If I go the positive route, I get 9 plus 3, and of course the answer would be then 12. If I take the negative route, negative 9 plus 3, and the answer would be 6. So I have 2 answers here. I have, thank you, negative 6. So I've got 12 and negative 6, okay? Let's pull up the graphing calculator to make sure that's right. Let's clear this out. So I had x minus 3 quantity squared equals 81. 81. So we'll pull up the graph real quick, and we'll move this over here. I wish you guys could all have this, right? Let's see here. Let's move the graph. Whoop, let's move the graph. Oh, hey, check it out. There we go. So, looks like this answer is the 12, and this answer is the negative 6. Yeah, it is a parabola. Yeah. It is the goal right there. All right. So I'll pause this. So the goal of completing the square is to create a perfect square trinomial. So I'll give you an example of what I mean. What do I mean by a perfect square trinomial? Here's an example of one. It's x squared plus 6x plus 9. Why is that a perfect square trinomial? Anybody see it? Because when I factor this, right, how does this factor? X plus 3 and 3. Oh, so it's x plus 3 quantity squared. Here's another one. What if I give you this one? X squared plus 8x plus 16. Could you factor that quickly? There you go, x plus 4 squared. So this is x plus 4 quantity squared. The goal is to create these things. Now the reason you want to create those things is because if you look back on the last example we did, notice we started with a perfect square trinomial. We started with x minus 3 squared equals 81. If you can get to this spot, that's what I call the home free spot, and we'll talk more about that in a second. So going back to this, okay, how do we then? There is a 1 in the leading coefficient. All right, be sure there is a 1 in the leading coefficient, otherwise we have to divide out that leading coefficient and make it a 1. Okay, so here's what we're going to do, okay? Here's the setup, so please follow along here. I want you to go x squared plus 10x plus something, draw a big giant box, equals negative 3 plus something over here. Okay, I did 2 things. Can you see the 2 things that I did? I moved the last term over to the other side, and I added something in there, right? And these things that I add, I call these the magic number. The magic number. He calls them that too? Yeah. We're basically the same person. Yeah. Okay, now, the question to you is, what is the magic number, and how do I get it? What is it? Yeah, the answer, the magic number is 25. Sweet. But we'll just pull that out of the air? No. Out of a rabbit's hat because it's a magic number? No. Yeah. Divide what by 2? Yes. Remember, this is written in ax squared plus bx, right? Where the a is the 1 and the b is the 10. So take b and divide it by 2 and square that. It will always give you that magic number. So what's half of 10? 5. What's 5 squared?
25.
That's how we found that magic number. Okay? Now, check this out. The reason you do this, the whole reason that you do this, is to create that perfect square trinomial. So, do you see it? What is the perfect square trinomial? X plus squared equals, oh my gosh, 22. Now, you're at that home free spot, and you know what to do.
Why'd you have to subtract the 3? Couldn't you just add 22 to both sides?
No, I want to create a perfect square trinomial. If the 3, if I leave the 3 on this side, it messes up the perfect square trinomial.
How? You did the same exact thing. You just add 22.
Okay, how do you get 22 though?
You added to 3 to get the perfect square. I don't know.
Yeah, I got the 22 over there.
I don't know. Why'd you have to take
To leave my answer like this.
Yes.
Yes, in fact, this answer right here is the exact answer. Okay? And an exact answer will not have a decimal in it, and you will not need a calculator. But what if we just wanted to get the approximate answer so that we could check to see if we get it right on our calculator? Well, let's see here. What is the square root of 22? I don't know. Let's bring it up. Let's do 22 square root. What would you round that to? 4.7. Okay, so x is equal to -5 plus or minus 4.7. So if I break off in my two directions, positive and negative, I get -5 plus 4.7. How much is that? It's like -0.03, right? Or -5 minus 4.7. How much is that? -9.7. So this is my solution set, right? -0.3 or comma -9.7, right? And that doesn't need that either. Okay. So, okay, let's see if this actually makes any sense whatsoever. So let's bring this up. We'll clear this out. So we had this. We had x squared plus, was it 10x, right? And then it was plus 3. Did I do that right? All right, let's bring this up. Oh, check this out. This is a nice looking parabola here. And if I zoom in and look over, ooh, what number does this look like to be? Look how close we can get with this thing. What did we say it was? Why are we off just a little bit?
Because the square root's a little bit off.
Because we rounded the square root of 27, right? Or 22, whatever it was. We rounded a little bit to that. So we're off a little bit, but notice that the graphing does coincide with what we found, okay?